So let's first start thinking about single amounts. What is the future value of a single amount? Again, this is an investment question. We're solving for an amount of money that we think we're going to get in the future by investing today. Interest, that's the earnings we're going to receive on this particular investment. Now, throughout these videos, we're going to just choose numbers, right? Later in some other videos, when we talk about risk and interest rates, we'll be able to understand or determine whether or not the numbers we pick are reasonable or not. Principals obviously is the amount that you will that interest is paid on. So let's start with future value of a single amount. And of course, what I've provided here is the formula. Now, this is our basic formula. But if you want to assume that sometimes interest is paid more often than once a year, we do need to adjust this formula. So to find the actual future value, the R, you must divide R by M, the number of periods per year that you calculate interest, and the exponent here needs to be N times M. So we have the actual number of periods per time horizon, and we have the interest per period during that time horizon. If you do the Excel formula, you have to remember that the rate that you include, right? The rate that you include has to be the time period. Number of periods, it's N times M. Then you have the payment. If there is a payment made, you have the present value. And then we have a final variable here called type. We'll talk about this a little bit later on, but the type talks about when the cash flow is made. When you make investments, calculating future value, the assumption is that you start today. So this type has a 0. So let's look at an example. Here's future value. So Fred puts $1,000 in a savings account that pays 7% interest compounded annually. Now, this is information you need to know, right? You need to know the amount of the investment. You need to know the interest rate on the investment. You also need to know the time of the investment. But we also need to understand about how many times per year we calculate interest. In our beginning videos and examples of time value, we're always going to assume that that number is 1. Now, if you look at our spreadsheet that I gave you, right, the present value is the investment, that's negative 1,000. Interest rate is 7%, time is 5, but the compounding frequency is 1. Now, in these formulas over here, the formulas calculate the rate per period and the number of periods in the investment. So if you invest $1,000 at 7% for 5 years, at the end of the time frame, you should have $1,402.55. If you're using a financial calculator, this is the keystroke for that particular for this particular problem. Now, I will tell you that it's been a very long time since I've used a financial calculator. So you need to review a financial calculator that you're using to make sure that you enter things properly. But these are the basic variables for any of these problems that we'll be talking about. So let's just take one more look at what's going on here with future value. This is the time periods. So the longer you invest, the greater the amount that you'll have. But additionally, the higher the interest rate, the quicker that amount grows. So over time, hopefully this is kind of common sense, the higher the interest rate, the more money you have at the end. But it grows at an exponential rate. If you remember, our formula has an exponent in it. So again, that's how future value works. So I have this basic problem, and if you pause this formula, maybe you can work on this problem yourself. I'm not going to spend a lot of time here, but if you pause, you'll be able to see this. If you have the PowerPoint presentation for this video, you'll be able to see that there are some answers in the notes that might give you a clue as to what your answer should be. And as for most of these examples, if you can plug in some of your own information, for instance, when were you born? How old are you now? You can plug those things in just to explore with the way these time value questions work. Now, the next piece of this journey, if you will, is to look at present value. We assume that you're going to get some money in the future. Let's assume that your company says, look, if you go and if you get a degree, we will give you $10,000 in 5 years if you go out and get yourself a degree. So the question is, what is that $10,000 worth in today's money? This is what's referred to as discounting, bringing dollars back to today. Now, in our problems that we work with and talk about, the discount rate, that the interest that we're talking about in our problems, it has many synonyms. It could be the opportunity cost, discount rate, the required return, cost of capital, growth rate. Many, many things could be referred to this growth or the return that you receive on these investments. So what does the present value look like? Here's our formula without getting into a lot of detail here, but essentially it's just the future value, and then you divide it by 1 plus the rate per period. Take that to the exponent of how many periods there are. And you'll notice that the Excel formula, the body is the same. All you do is change the formula starts with PV instead of future value. So again, you're going to receive $2,000 in 5 years. Your opportunity cost is 10%. What's the value of that in today's money? Future value is 2,000. Notice that the number is positive. This is because you're going to receive the money. Interest rate's 10, time is 5, compounding once. This is worth $1,241 today. If you invest $1,241.84 for 5 years at 10%, you will have $2,000 at the end. So essentially, all we're doing is taking a cash flow and we're either moving it forward from today or we're bringing it back from the future. So again, this is the way time value works. Once you understand the formulas, it's a very mechanical process. Identify the numbers in the question or in the problem, plug them into the formula. Again, we have another example here. Again, I'll let you work this. If you pause this, you can work this on your own. Again, the answer is in the PowerPoint. If you expect to get a $100,000 inheritance in 20 years, if inflation is 2.5%, what is that worth in today's money? Again, you can plug in your own numbers if you want, or just as an experiment, think about current inflation. Current inflation is very, very high. Plug in the current inflation that we're experiencing, and then look how that affects future values. Again, how does it work graphically? The longer the time frame, the less value there is with the dollar. So money that's farther out in the future is worth less than money today. And indeed, as interest rates rise, that growth is negative, right? It declines, but it declines at an exponential rate. So again, I hope this video is helpful. You'll see many more videos available about how to solve for the time value of money. See you next time.